Good day to all of you. Today we shall study relational algebra. Our sincere thanks and acknowledgement to authors Ramesh L. Masri and Shamkat B. Nawate, authors of the textbook being Fundamentals of Database Systems. The content of discussion I have taken from this textbook. Let's start the session. First, let us know basic terms in relational model. Relation means a table. It will be having columns and rows. Rows are called as tuples, columns are called as attributes. So the table name is student. So these minimum terms we should know for following relational algebra. In relational algebra, the set of database management system operations, they are represented in the form of relational algebraic expressions. So database means collection of tables. So the software which manages the storage of data in the form of tables and gives access to the users for manipulation, that is called as database management system software. So the set of tables and the software together form database management system. So here the user will be storing the data, that is creating the table and keeping the data in the tables in memory. Then whenever he or she wants, they will be accessing the tables called relations which are stored in the memory through DBMS software. So which operations they perform? They are called as DBMS operations. So they are specified using relational algebraic expressions. So which are the fundamental operations that are presented in relational algebra? They are select, project, rename, union, intersect, difference, Cartesian, join and division. Next we shall see to these one by one through examples and how in relational algebraic expressions they are specified. Relational algebraic expressions guide writing of SQL queries. First we'll see to select operation. The select operation is used to choose a subset of tuples from a relation that satisfies a selection condition. Select operation is represented by sigma. So at the foot we write here condition and here input relation will be specified. This is relational algebraic expression for select operation. So this is the input relation. It will be having many rows or tuples. Out of that only few rows, that is subset of tuples present in this input relation. Only those rows which satisfy the condition, they will be outputted. Okay. So for any relational algebraic expression, one relation will be the input and another relation will be the output. Select will choose those rows which satisfy the condition as output relation. Okay. As already mentioned, in general the select operation is denoted as follows in relational algebra. So this is sigma is the symbol for select operation. So at the foot of sigma the condition is specified and R is the input relation. So next we shall take example 1, relational algebraic expression for select operation. So this is selecting only those rows from employee relation in which row department number value is 4. Hence, this is the relational algebraic expression to retrieve employees belonging to department 4. So, in each row of employee relation, one employee detail will be stored. So, how many rows are there? So many employee details will be stored. So this algebraic expression is choosing only those rows, means only those employees. In which row department number 4 means employees belonging to department number 4. Only those rows will be outputted. Hence we say that this algebraic expression is to retrieve employees belonging to department number 4. Next we shall consider example 2, relational algebraic expression. What for this is for? Can you guess? So this Relational algebraic expression specifies select operation only. Means it is going to choose only those rows from input relation employee. Means it will select only those employee details in which row salary value is greater than 30,000. Means this is the relational algebraic expression to retrieve employees details who draw salary greater than 30,000. Means from employee relation only those rows in which salary has the value greater than 30,000 they will be outputted. So what will be the output of this relational algebraic expression? Can you guess? So please pause the video and make a guess. So in this relational algebraic expression, employee is the input relation. As it will be having many rows, out of many rows, only those rows which satisfy this condition, they will be outputted. So what is the condition is specifying and which rows will be outputted, that we shall discuss now. So here in the condition there are two parts, this one part or this is another part, because this is in one set of brackets, this is another set of brackets. So condition 1, condition 2, in between we have this logical operator. This OR operator specifies either of the conditions which rows satisfy, those rows will have to be outputted. Either of the condition means in employee relation in which row department number is 4 and salary greater than 25,000. In that row both of these conditions must be satisfied. That is what is AND operator specifies. So in which row department number is 4 and salary greater than 25,000. So those rows must be outputted, or those rows which are having department number 5 and salary greater than 30,000. Means these two conditions. Which rows satisfy, those rows must be outputted. So the resulting table will have from employee relation only those rows in which row department number is 4 and salary greater than 25,000, or department number is 5 and salary greater than 30,000. Okay. So finally what we can say, if employee is the input relation, in the output relation we have only those rows which satisfy this condition or this condition. That is, it will retrieve the employee details who belong to department 4 and draw salary 25,000, or employees belonging to department number 5 and drawing salary greater than 30,000. That is what is this relational algebraic expression is for. So this relational algebraic expression, that is example 3, it retrieves employees who belong to department number 4 and draw salary greater than 25,000, or the employees belonging to department number 5 and draw salary greater than 30,000. Okay. So in this bracket, which one condition is written? This AND operator specifies that both the conditions must be satisfied. That is one condition. In another condition also AND operator is there. It specifies here both the conditions must be satisfied. So if this is one condition, this is another, that is second condition. In between OR operator specifies that if condition 1 is satisfied or second one is satisfied, not both. So AND means both the conditions, OR means either of the two or either of many, any one condition. So that is what is all about logical operators and OR operator. Okay. So example third, select operation. For that relational algebraic expression, just now what we discussed, if you take this employee relation as the input relation, then what is going to be the output relation? So here department number 4 and salary greater than 25,000. So department number 4 means 3 rows are there. In one row salary greater than 25,000 is present. Hence that will be present in the output relation here. Or department number 5 and salary greater than 30,000 means department number 5, so 4 rows are there where salary is greater than 30,000 means in this row and in this row. So those two rows, they are present in the output relation here. So according to this relational algebraic expression, if there are 8 rows in the input relation, the output relation is having only 3 rows, because only those 3 rows satisfy the condition given in the relational algebraic expression for select operation. So that is all about select operation, which is meant for choosing the rows according to condition from the input relation. Okay. So if you take this relational algebraic expression where only one condition we have, that is department number 4 and salary greater than 25,000. So select operation is specified here. Input relation is employee. Just now which one we had taken. The same employee relation is the input relation. So can you guess what is going to be the output relation? Please pause the video and write the output relation. So what we can guess? Select those rows in which department number is 4 and salary greater than 25,000 from employee relation. So this is the employee relation where department number is 4 means this row, second and third, only these rows, and salary is greater than 25,000. So in this row salary is 25,000, so we cannot take, it is not greater than 25,000. So in this row it is greater than 25,000 because it is 43,000. But here also in this row we cannot take because it is not greater than 25,000. It is equal to 25,000. Hence only this row will be taken and that has to be outputted. So according to this relational algebraic expression, if this is the input relation, that is employee relation, which is having 8 rows. This is the output relation, which is having only one row, because out of 8 rows here, only one row is satisfying this condition. Okay. So what for relational algebraic expressions will be written? Because they can guide writing of SQL queries. What are SQL queries? SQL queries are the structured query language commands. So if this is computer memory, in that our tables, that is collection of tables, database will be stored. User will be giving SQL commands to DBMS software. Those commands will be executed by DBMS software and it brings the required data from the database and gives to user. Okay. So SQL queries are written by the user and given to DBMS software as to communicate with the database stored in computer memory. So to write those SQL queries, these relational algebraic expressions act as guidelines. Okay. So as an example for this relational algebraic expression, what is the SQL query? We shall see now. Following the guidelines specified in this relational algebraic expression, what SQL query we get, that is written here. So this is select clause, from clause, where clause. So these are the reserved words. They may be written in either small case or capital case. So SQL query language is case insensitive. So select Star means all the columns. So all the columns are selected from the input relation, that is employee, where this condition. So this condition is specified. So this SQL command is given to DBMS software, not this. This is for guiding how to write this SQL query. Okay? Because relational algebraic expressions specify all the operations step by step, they can better guide efficient writing of SQL queries. Okay? So if this is the relational algebraic expression, for that this is the SQL query. Okay? So that completes the discussion on select operation in relational algebra. In the next coming video sessions, we shall discuss on project operation, combination of select and project operations. Okay? I hope you understood. Thank you.